Let us start with the marine boundary layer chemistry of chlorine. The main source of chlorine is sea salt and the sea spray aerosols. Chlorine is released by acid displacement by nitric acid or sulfuric acid or by photochemical processes. What is the role of chlorine in the atmospheric chemistry? It contributes to ozone destruction and oxidation of DMS. There is a rapid reaction with the methane, enhancing the chemical loss. And how do we know these are all happening? The measurement is we can do a mist chamber techniques, hydrocarbon clock isotope techniques, chemical ionization mass spectroscopy CIMS techniques. And what are the concentration that is generally expected for the chlorine? The hydrocarbon clock is 10 to the power 3 per centimeter cube to 7.6 into 10 to the power 5 per centimeter cube. High chlorine levels are like chlorine oxide, chlorine radical, HOCl are found near continents. Examples: Florida and the Gulf of Maine, and similarly this is in the US. Lower levels of in the cleaner areas like Bermuda or Hawaii, but in the Arctic region the values are quite different. And direct measurements include CMS, which can detect chlorine up to 150 ppt, and HOCl measurements and Cl102 from which is linked to N2O5 formation and salt containing aerosols. And what are the various model studies? One is the contribution to ozone destruction, CLO mixing ratios predicted often below detection limits, and vertical profiles of halogens vary in marine boundary layers. So this is information related to chlorine. And what is the marine boundary layer of chemistry of bromine? The presence and evidence was found from sea salt aerosols in the depleted in bromide, but initial detection of bromine oxide in the marine boundary layers. Bromine oxide levels up to 10 ppt near Mauritania and 6 ppt in Ireland. So this is how people know that this bromine is actually existing in the Arctic region. The contribution to ozone destruction is around 30 to 50% of halogen oxides are responsible for the destruction of ozone. And what are the mechanisms? The high level of observed even with parts per billion of NOx, suggesting that recycling mechanism. So that means the bromine oxide can keep on continuing in the destruction of ozone. The low detection limit raises a question about bromine's presence. Similarly, the potential overestimation of bromine release from sea salt in models is also another challenge. So with respect to iodine, the coastal regions, especially high biological activity, leads to reactive iodine burst. Open ocean, there is a smaller diffuse of iodine fluxes, especially in the marine boundary layers. And initial reports of 5-volt coastal sites were found from Mace Islands. There is an increasingly people are detecting it in the open ocean also. What is the mechanism? Iodine is a likely precursor for highest IO in the coastal environment. Iodine oxide is obtained from iodine. Self-sustained iodine chemistry is in semi-polluted areas are known. Similarly, recent measurements of iodine and I atoms and ultrafine particles in Galaxia tells that iodine is involved in all this process. And currently people are predicting that iodine and I levels are inversely correlated with the tidal height. Similarly, there is no or very weak correlation between ultrafine particles and iodine levels, suggest there is a complex interaction involved. Let us look at many of the reactions which are involved in the halogen chemistry. The reactivity of halogens decrease with increasing mass. So the fluorine atoms from HF very rapidly and decompose very rapidly. So they play no role in the tropospheric chemistry. Chlorine atoms are highly reactive towards hydrocarbons, whereas bromine reacts mainly with ozone and only with the selected hydrocarbons such as aldehydes and DMS. Iodine atom mainly reacts with ozone. The depletion of ozone is catalyzed by halogens through the halogen and oxide radicals. So here is the first reaction which is given. X dot reacts, that is the halogen dot reacts with ozone to give XO dot and oxygen. Y dot also reacts with ozone to give YO dot and oxygen. When combining these two reactions, what we get is basically XO dot plus YO dot giving X dot and Y dot and oxygen. So overall reaction will be like 2 ozones are getting converted to 3 oxygen. So that is the net reaction that is happening. So when X and Y are chlorine, Cl2O2 is formed in this particular reaction, that is the diradical combination reaction. When X and Y are bromine, bromine radical and Br2 bromine are formed. When X is bromine and Y is equal to iodine, OiO, that is iodine dioxide, and bromine radicals are formed. When X and Y are iodine, OiO, iodine dioxide, and I2O2 are formed. So these are all the various reactions that happen with respect to each different halogen atom. So what are the halogen radical reactions? Photolysis of dihalogens is a key initiation step, because this is how the halogen radicals are generated. X2 plus H nu gives 2X dot. So this is the source of the one in the main reaction. So this further reacts with ozone. So since the absorption spectra of dihalogens lie especially in the visible or UV region, the photolysis of halogens occurs readily even under low light. So on the other hand, ozone photolysis requires photon in the range of 300 nanometers. So that's the reason this reaction is the initiation reaction. Once the ozone depletion reaction is given by X dot, that is the halogen dot radical plus ozone gives XO dot plus oxygen. The halogen can also competitively react with hydrocarbons. So X dot reacts with hydrocarbon where alkyl radicals are produced plus HX. So if we talked about the photodissociation of halogen oxide, so XO dot XO can be happening leading to the formation of X2 and O2, that means dihalogen and oxygen can be formed, or 2X dot can be formed with oxygen, or XO2 is formed with X radical. So these are all the various combination reactions that are possible when two halogen oxygen radical actually reacts. So here also other reactions that are possible are given here. So halogens are being used in the recycling from reservoirs also. So the termination reaction for the radical reaction is XO dot reacts with the HO2 to give HOX and oxygen. The photolysis of HOX is given by the HOX when reacts with light produces X dot and OH dot. So here basically two radicals are produced. X dot is one radical and OH dot is also another hydroxyl radical. Other reactions of HOX include the hydroxy radical reacts with carbon monoxide to give carbon dioxide and H dot. The H dot further reacts with oxygen to give HO2 plus M. This HO2 can be consumed in the first reaction as shown here. Similarly, heterogeneous reactions with anions are also known. HOX reacts with HX or X minus to give X2, that is the dihalogens, and hydroxide radical or water is produced. Similarly, there is an important reaction called bromine explosion reaction. We will be studying about this particular reaction. So the bromine radical reacts with HO2 in the presence of an anion in the presence of solar radiation or sunlight, leads to 2X dot and OH dot and water. And other reactions of hydrogen halide include when the hydroxy radical reacts with HX, that produces a halogen radical. So these are all the various reactions that are involved. And many reaction cycles are there. The photolysis of halogen dioxide once formed can decrease the efficiency of ozone depletion because the radicals are basically removed. That's the reason there is the efficiency of the ozone depletion can be reduced. When bromine oxide and iodine oxide mixing ratio is high, ozone destruction actually occurs. At lower mixing ratios, the reaction of HO2 predominates. So there is a competitive reaction, and whenever the ratio is less, they don't destroy ozone. So the XO can react with H nu, that in the presence of photons, they form the XO, and the triplet oxygen is also formed. And OXO when reacts with H nu, when X is equal to iodine, it gives iodine and oxygen. When nitrogen oxide is present, it gives XO and NO2. So basically in this reaction, the rate coefficient for this reaction increases with the mass of the halogen when iodine is having the highest reactivity, followed by bromine, followed by chlorine. There are also other reactions which are involved. This particular cycle, when carbon monoxide reacts with OH and native oxygen, nascent oxygen gives carbon dioxide and HO2. This cycle actually results in the substantial ozone destruction in remote marine environment. So here is the major reaction. The ozone reacts with X dot to give XO, and this is what is the overall reaction. Carbon monoxide reacts with ozone giving carbon dioxide and oxygen. So this is what is the one of the destruction reaction of ozone. We have been mentioning about bromine explosion. So what is a bromine explosion? Bromine explosion basically refers to a phenomenon in atmospheric chemistry where the reactive bromine species, particularly the bromine oxide, are rapidly released, which contribute to significantly ozone depletion in the polar and marine boundary layers. So the reaction is given here. X here is any radical, or we can, in this particular case, we can also consider this as a bromine. So this reacts with HO2 in the presence of X minus and light, leading to two radical formations, which completely leads to the one radical is now converted to two radicals. So that is how the explosion or the increase of the number of radicals are actually happening. So what is the source of this bromine explosion? The bromine is primarily from the sea salt aerosols, where bromide is released during the process such as evaporation of seawater and the action of sunlight. So this is what is in this reaction we have a X minus. So what is the source of this X minus? The source of X minus is given here, sea salt aerosol. And what is the mechanism? When the bromide is exposed to the ultraviolet rays, it is converted to reactive bromine species, that is bromine dot is actually formed. So the bromide ion falls from the sea salt aerosol and the bromine radical is formed by the ultraviolet light. So this leads to the formation of bromine oxide. So this conversion can occur in the presence of atmospheric conditions such as presence of frost flowers or saline snow. This leads to the destruction of ozone. So that is the reason the ozone depletion is happening because of the formation of bromine oxide. A small amount of bromine can actually lead to breakdown of large number of ozone molecules due to catalytic reaction. So that is what is called the responsible for the bromine explosion leads to destruction of ozone. What is the environmental impact? The bromine explosion is particularly significant in the polar region because there is a dramatic decrease of ozone concentration during springtime. This impacts both local and global atmospheric chemistry. So here are the explanation of various aspects of bromine explosion reaction. First one is the formation of bromine species. Source is basically from the aerosols, and the mechanism we had seen. There is also another method by which this happens. There is an acid displacement reaction. In the presence of acid species, bromide can be displaced from sea salt, facilitating its transformation into reactive form. So that is also another thing happening. And what are the key species involved in that? Bromine, the dimeric bromine, which can further dissociate into bromine and bromine oxide. Upon photolysis, bromine oxide, HOBr, hypobromous acid. These are all the main bromine species which are involved in that. So what are the chemical reaction involved? Bromine plus ozone gives bromine oxide plus oxygen. Bromine oxide plus UV light gives bromine radical and oxygen radical. Oxygen again reacts, this oxygen radical reacts with ozone to again destruct the ozone to give oxygen. So that means there are two places the ozone is actually destructed. So we know the environmental conditions and that is required for the bromine explosion reaction. One is the meteorological factors. This is in the spring when the solar radiation increases and the temperature rises. This leads to melting of ice. That means more and more bromine can be released. The frost flowers are also responsible. Similarly, the blowing snow events are also responsible for the production of bromine oxide radicals. Bromine oxide. There is field observation and studies which clearly tells that these are all the events that are happening, and finally we saw the implication because ozone layer is depleted and it also leads to climate impact.